All right. Okay. So now going to the next question actually, which is so this one. Now in this, two experiments are carried out using two trolleys of equal mass, and all moving parts of trolleys are frictionless. Pretty good. And the surface trolleys move over. In both experiments, trolley X moves towards trolley Y, which is initially stationary. Okay, so after collision of experiment 1, um, after collision of experiment 1, X is stationary and Y moves off to the right. After collision experiment 2, the trolleys join and move off together. Which type of collisions occur in these experiments? So first of all, let's keep U and let's keep it 0. So U1 as U and U2 as 0. Both have the same mass, right? So let's call this M. So for the first experiment, it will be M times U plus 0 equals to M. Well, we don't really need to do anything. We can just simply use U1 plus V1 equals to U2 plus V2 actually. And then U1 will be U, V1 will be 0 because after it stops, and U2 is initially 0 and V2 is U, so that is correct. It is elastic. Experiment 2, whenever some trolleys join together or anything that joins together, just remember it's always inelastic, so it has to be B for sure. Okay, so just a tip for you. Then this one. So three forces act on the arm shown. What is the magnitude resultant moment of these forces? So first of all, this is going to turn it this way, this is going to turn it this way, and this is going to turn it this way. So this is anti-clockwise, anti-clockwise, clockwise. So for I'm going to write anti-clockwise, I'm going to write clockwise. So anti-clockwise forces are going to be, this is basically 1.5 till the pivot, right? So you have to check the moment, perpendicular distance from the pivot. So 5 times 1.5, and the other anti-clockwise is 10 times, this is the perpendicular distance from 10, so 10 times 2, and clockwise is 15 times 3 actually. Oh no, wait, this is not right. This is absolutely wrong. The total distance from basically the total distance is 4 actually for this member. So at half, this will be 2. So this will be 2 actually. So this will be 10, this will be 20, this will be 45. So 10 plus 20 is 30, this is 45. So 45 minus 30 is 15. So which means it is 15 Newton meters right there. All right. Now, then two parallel forces, each of magnitude F, act on the body shown. What is the magnitude of torque on the body produced by these forces? Okay, so the perpendicular distance between these two forces is S. So one of the forces times the perpendicular distance between them should give you the answer. So 14 has to be B then. Okay, then going to the next one. A street lamp is fixed by the wall, and Okay, then which vector triangle represents the forces at point P? So the weight is going to act in this direction. Okay, the tension will act in this direction. Now tension will have two components like this, so they should also oppose it, which means that this is in equilibrium, right? So weight is down, tension is like this, so the other force that must be there got to be, but they have drawn weight on this side, so let's draw weight on this side. Weight, but tension is on the opposite side, which is pretty bad actually. So okay, never mind. This rod will actually oppose this, so there will be a force like this, and then there will be a force like this. So this should actually be in closed circle with just one movement, okay? Which means that the answer that makes the most sense here has to be D, because that shows equilibrium. Now sometimes you might also not get it, so you could actually try moving like making a direction like this and going like this. Now this is this shows this to be in equilibrium. This doesn't show it to be in equilibrium because the arrow is opposing it, so that's not equilibrium. This also is opposing it, that's not equilibrium. So you can choose between A and D, but because weight is down and here the weight is shown up, so it has to be D. Then you could also think like that, okay, if you want to. Right, now going to what is the internal energy of the system. Internal energy is basically the, why is this question even here? Isn't it in A2? So it is energy of atoms in the system, but you won't get this question, so miss. Now it says a steam turbine is used to drive a generator. The input power is Pi, the output power is Po, the power loss is PL. What is the efficiency of this? So P out over Pi. Where is that? Po over Pi has to be D then. This is not that hard. You were saying it's too hard. I was like, wow. Okay.
Sure, it's easy for you.
No, it's like normal questions.
You teach physics.
Okay. Well, that could be.
Everything's easy for you.
No, it's not. But still. So the diagram shows a lift system elevator is counterbalanced by heavy weight M2. At rate which the motor provides energy system when the elevator is rising at the steady speed is V. At what rate does the motor provide energy to the system? So it has to be, we have to make sure that it stays in equilibrium, right? So for that, let's see what we can do. So this is moving in this direction, right? So M2 is larger, so which means its weight will be M2 times G. Its weight is going to be M1 times G. So M2G minus M1G will be the resultant force, right? And this will be the resultant force, fine. Now this is the force that the motor needs to overcome so that it goes into steady velocity at this speed. So power is given by force times velocity, and the force was M2G minus M1G and velocity. And now what to do? We there's G taken as common, so M2 minus M1 GV should be the answer, so it has to be D then. Alright, if you have any questions, please do let me know, okay? Now, next, 19. The Mariana Trench in the in the Pacific Ocean has a depth of 10 kilometers. Assuming the seawater is incompressible and the density is about this, what would be the approximate pressure at the depth? So pressure is equal to rho gh, the density is 1020, g is 9.81, and height is 10 times 10 raised to power 3. So let's see the pressure. 9.81 times 10 times 10 raised to power 3. So this is 1.0 times 10 raised to power 8. So did we need to assume anything? No. So 10 raised to power 8. That's fine. Alright, now student writes statement about solid, liquid and gases. This is not going to come in your exam anymore. This is like old question. Now what is the energy stored in the spring when the extension is 30 millimeter? So the 30 millimeter mark is here, and this basically lead us to somewhere here, and I don't know what that is. If the 7 is here, it is less than 65. So can we take 6.2 then? I think we should take 6.2. So half times 6.2 times, there's one more thing we can do, but I'm not going to do that. 30 is 30 millimeter, 10 raised to power minus 3. Okay, let's move it here. 0.5 times 6.2 times 30 times 10 raised to power minus 3. So that is 0.093. 0.093. So that has to be A. Approximately, I just did it like that. Okay. Now next. So there are two rods. Uniform cross-sectional area of the wire. Sorry. Metal X is joined metal Y. Okay. The load is hung from the metal causes X to stretch by this and Y to stretch by this. Okay, so this is a series system. In the series system, the extension is always added, which means that 1.5 plus 1.0, the total extension in the system will be 2.5 millimeter. Fine. But can we do that? Do we need that? I don't know. The same load is then hung from a second wire of the same cross section consisting of 1 meter of X and 3 meter Y. What is the total extension of the second wire? Wow! Interesting. Very, very interesting this is. Let me think about it, right? So basically we have to use E equals to FL times AX. The metals are different, right? If the metals are different, this means that got to be right. So the force in both of them is same because in series force remains the same. The length of X was 3. The length of the area was the same, and this is EX by the way, and the extension was given by 1.5. So I'm not going to change the units. The reason behind this is that this is a ratio and you don't need to do that. So EX will be equal to F over A times 3.0 over 1.5. Okay, let's keep it like that. Then what you do, EY has to be equal to F times the length is 1 and the area is A, and the extension was 1. So then EY is sort of F upon A into 1. Okay, now what we can do is, now because you see, let's write it 2. Now if you see that F over A and F over A is the common term, right? So we can replace it. So I can write it as EY, sorry, we can write EX is equal to EY times 2. So that's the thing we needed. Okay, now let's keep it right there. Okay. Oh, they have given so much space for working. Wow. Because they know it needs working. Okay. So let's keep it there. This is our first clue. Now what you do then? Now in the second thing, they say that the same load is hung, second wire. Now X is 1 meter and the other wire is 3 meter. Okay, let's try to do that. So EX now will be F times 1, and we want to find, area is the same, we want to find the extension in X. We want to find the total extension really. Okay, so EY will be F times 3, was it 3? Yeah, 3, over area time extension in EY. Okay, now let's try to make some sense out of it. So, well, interesting. Very, very interesting actually. What do we do now? So let's say EX times XS, EX times XX is equal to F upon A, and EY times XY is F upon A. Right, so we can actually combine them. And this will be EY times XY. Now it's easy because we have already found the relationship between EX and 2EY. This is a difficult question actually. So we can replace this right here. So this will be 2EY times XX equals to EY times XY. Now EY and EY will cancel out. So this will be 2XX equals to XY. Now they have given, it says, what is the total extension of the second wire? Now, how do we actually find that? Let's try. So, the total extension will be equal to XX plus XY, and XX is just there. Instead of XY, we can write 2XX. This is 3XX will be the total extension. The XX was, the extension before in X was 1.5, right? So no, this is gone out of control now. There has to be something else. Otherwise, how could this question be? It's not making any sense here. The first extensions are given only. So how would it change? Now XX will be twice of XY. XX, which was basically this, is twice the XY, and XY will be half. Okay, I think I can make some sense here. So it means that if I put 1.5 here, so XY will be actually 3 millimeter, and with that same respect I can use the same equation XY, and for XX this was 1, so XX would be 1 divided by 2, this is 0.5, so added both together would give me basically would give me 3 0.5 plus 3, which is actually 3.5 millimeter. So the answer has to be B then. Wow, this is extreme hard question. Okay, I feel you, Anusha. This is hard.
Yes, sir, I don't understand. And none of this. What is
Okay,
happening?
I also did it for the first time, but I could do it. Um, well, I'll tell you again. This is kind of scary. Don't be scared, but it's fine. So let me make it easy for you now. It's actually I did it on my own. If I was in the exam, I would do it like this. But now
I would have guessed it.
I would have done it because they have given so much space. This is why they have given so much space, because it requires a lot of working.
There's no time.
Yeah, I know.
Much work.
Yeah, I can I can understand. So EX is FL times AX, right? Is it clear? Now,
Yeah.
and EY is also FL times AX. Now, it's very simple because here you see the length of X is basically 3 times, right? And the extension in X is 1.5 times. So basically it is 2, a factor of 2, right? And then here the length is 1, but the extension is also 1, right? So it is like this. So it means EX is basically 2 times of EY. Do you understand what I'm saying?
Yeah.
Now, in the new format, I can see if this is the case, right? In the new format, it will be a bit different because now EX will, the F upon A is same. The length of EX is now 1, and this is what we need to find, right? X. The EY is equal to F upon A, and the new length is 3, and we want to find XY here. Do you understand what I'm doing right now?
Yeah. Yes.
Which basically means that actually okay, wait a second, did I make a mistake here? I think I made a sort of a mistake here. The length was 3, that is 2, and that was 1 and 1, so EY and EX was like this. Fine, never mind. So this means that EY times XY times 3 divided by 3 is equivalent to basically EX times X, EX and XX. Sorry. Do you understand this up till now?
No, I lost you here. What are you doing?
Okay, wait. So for the second wire, na, it says there is same load in the second wire that they've used, which is 1 meter of X and 3 meters of Y. Do you understand?
Yes.
With that in mind, right, we need to see that how would it affect these two things, because they have they know that this is the factor that we originally wanted to see. Okay, so which means that, wait a second, this is not entirely correct. Wait, again, sorry, I made a wrong equation. EX is equal to F upon A, length is 3 and this is 1.5, so this is basically EX is equal to 2 times F upon A, right? EY, which is F upon A, the length is 1 and the extension is also 1, so EY is just equal to F upon A, which means EX is equal to 2 times EY. So this is the first factor we are looking for, right? Now,
Yeah.
now this is for the first type. Now we are going to look at the next wire. Okay, for the next wire, second, we have to make the same equation. So E of x will be equal to f upon a, so they have this factor same, multiply by, now the length of x is 1 and extension we don't know, right? For ey, force over area is the same. The new length of y is 3 and this is xy. Do you understand this?
Yeah.
Right, so I can basically make an equation. I can simplify if I make subject of these two, or I can just multiply ex, like I can make, bulky, it's easy to make this xx equals to f upon a. Can I write it like this equation?
Yes.
And I can similarly write this equation as ey times xy, ey times xy, divided by 3 as f upon a. Do you agree?
Yeah.
Okay, now we have the common factors here just for comparison. So we can write ex xx equals to ey xy divided by 3, right? Agreed?
Yeah.
Now think about it this way. Now the factor ex is 2ey, so I can plug it right here. So this is 2ey times xx equals to ey over xy over 3. So basically this and this cancels out, and sorry, this is not cancelling out, this and this will cancel out. So now I have a different factor. This is 5 times xx is, sorry, 6 times xx is x equivalent to xy, right?
Yeah.
Right. Now let's see. Now originally xx was equal to 1.5 millimeter and xy was equal to 1 millimeter, right?
Yes.
Right. Okay. Now what I did was I put, first I checked what would be xy. So I put it right here. So 6 times 1.5 would be xy. Why am I getting a different value now? Why? 6 into 1.5 is actually 9 millimeter xy. And here I'm getting, and if I put xy in this will be, but I'm getting a different answer. This is not right. First I got a different answer, now I'm getting different equation altogether. Why am I getting this?
This is so sad.
This is so difficult. Oh my god. Okay, never mind. Let's come back to this question again in a bit, okay? Let's clear our mind here. Tough one here. So let's come back to this. Okay, I'll be back on this. Now, let's check this one. Which statement is correct? The wave has an amplitude of 2, could be either transverse or longitudinal. So this means, okay, so displacement is given and time is given, and it says The wave is amplitude 2, that is correct, and either transverse or longitudinal. Yes, it could be, it is displayed on a CRO, it could be like that. The wave has an amplitude 2, must be transverse. That is not correct, it could be both. The wave has amplitude of 4, wrong, amplitude 4, so A has to be the right answer. Anyway, you can display both waves like this. Now, at which point shows a vertical cross section of water, left to right, which point of water moving upward with maximum speed. So when you are at the, because this is like, the wave is like this, right? So you must see that the wave will move like this. Let me show you. The wave will move like this, right? Because it's moving forward. So A will go down, B will go down, C will go up, D will go down, further down. Yeah. So no, D will actually come up then. Anyway, these 2 points are not our answer. The reason behind this is that these are at maximum, and when they're at maximum displacement, the velocity has to be 0. Which means that then we are left with A and C, and both will have maximum speed, but it says which is moving upwards, so the upward point is C, so C has to be the correct answer. Like that.
Wait, how do you know? How does it move? Up or down?
I just shifted the whole wave like this. Do you see? It will look like this afterwards, right? In a split of a second, or maybe in a second or one, something like that,
Yeah.
right? So I know that A will go down, B will come down, C will go up, D will go up, right?
Yeah.
So
Got it.
B and D are extreme points. At extreme points, velocity is 0. So it has to be A or C, because C is going up, so C is the right answer, like that. Okay.
Yes.
Then this is a polarization question. What is the intensity of emerging light at 60 degrees? We have to use Malice's law, which is I equals to I naught cos square theta. You have to remember this, right? So it says what is the intensity of this. So intensity is I. For I, we have to find this intensity afterwards. Let's call this x, and cos square of 60. So we have to do cos 60, and then we have to take a square of it. So that's 0.25 I, which is A. Do you understand this? Pretty simple, right? But you have to remember Malice's law. Now, this question is a stationary wave is produced by 2 loudspeakers emitting sound of same frequency. When the microphone is moved between x and y, the distance 1.5 meter, 6 nodes and 7 antinodes. What is the wavelength? So we can actually find, this is a antinode, 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 and antinode. So it says 7 antinodes. We have 7 antinodes. So this is half lambda, half lambda, half lambda, half lambda, half lambda, and half lambda. So how many half lambdas are there? 1, 2, 3, 4, 5, 6. So 6 times half lambda would be 6/2, or 3 lambda. So now 3 lambda is equivalent to 1.5 meter. So lambda will be 1.5 divided by 3. So this is 0.5, so has to be A. Okay. Now, which electromagnetic wave would cause the most significant diffraction effect for atomic lattice of spacing this? Now you have to learn this, of course, the wavelengths, and 10 raised to minus 10 is the wavelength of X-ray, which is D. Now electron has an electric field, so we don't want to do this. We don't want to do this. We have to, and we don't want to do this. This is all electric fields, but we want to do this. What is the direction of flow and the rate of flow of electrons through resistor R? So it's asking about electron flow in this. So which means electron flow will go from negative to positive, so we have to go from y to x, y to x, y to x. These two are absolutely wrong. And now we want to find the rate of flow of electrons. Rate of flow of electrons, fine. So current equals to charge upon time. The total charge traveling in 1 second is equal to 4.8 times 1, which is 4.8 coulombs. One electron has a charge of 1.6 times 10 raised to minus 19. So how many electrons will be in 4.8 coulombs? Right. So you got to cross multiply. So 4.8 divided by 1.6 divided by 10 raised to power minus 19. So that is huge number. I hope this calculator works. Thank God. 3.0 times 10 raised to 19. So that's this, which is C. Alright, now going forward, it says which component has IV graph. This is a classic filament lamp graph, because the current, as the voltage is increasing, current is being limited to certain value because temperature is increasing and resistance is increasing. Then copper wire has is cylindrical and resistance R. What will be the resistance of copper wire of twice the length and twice the radius? So we're going to use R rho L over A, and there's radius, so we'll put it that. So wire 1, wire 2. So this is R, this is rho, this is length A and R. For the second wire, it says that what you need to find the resistance. Resistivity is the same because it is copper. Twice the length and twice the radius. Twice the radius would mean 4 times the area because it's a factor of square. Okay. So this would mean that R2 can be written as rho L, 2L over 4A, and R can be written as rho L upon A. Now we can just make all these things 2 by 4 times rho L upon A. R is equivalent to rho L upon A, so we can substitute. So R2 will be half of R. So that's B. A relay is required to operate 800 meter from power supply. The power supply has negligible internal resistance. The relay requires 16 volts and this much current to operate. The cable connects the relay to power supply, and 2 of the wires in the cable are used to supply the relay. Okay. The resistance of this wire. So basically they're saying that there is a power supply. So this is connected to certain cables, then there is a relay, and then there is like this. Okay, and the total, okay, I should have made, anyway, it doesn't really matter. Let's make it positive, let's make it negative. Okay, now they say the relay requires 16 volts of voltage, and the current in this wire is 0.60 ampere. The cable connects, and the relay is required 800 meters from the power supply. So 800 meter means that this length will be 800 meter, and this length will also be 800 meter. So then you have the resistance given, so we can find the resistance on wire, that is 1, and wire 2. So what you do is you multiply 0.0050 multiply by 800. This is 4 ohms, so this is 4 ohms. This will also be 4 ohms. Now what is the minimum output EMF? Right, so we have 16 volts here. We want to find the voltage supplied to this one and this one. So V is equal to IR. The current is 0.60 times 4. So 0.60 times 4 is 2.4 volts. So 2.4 volts to this wire, 2.4 volts to this wire. So total will be 2.4 plus 2.4 plus 16. So that got to be 20.8 volts. That is C. Alright. Please let me know if you have a question here.
Sir, please explain this again.
Okay, for this you need to make a drawing actually. Again, I'll tell you. So there is, let's suppose this is the positive terminal. The wire goes to 800 meter, right? It is then connected to a relay, okay? And then the wire must go back to the supply to 800 meter as well, because the issue is that it says it should operate 8 meter away from power supply. So 800 meter going, 800 meter coming back, right?
Yeah.
Now this relay is operating at 16 volts and the current is 0.60. So what I did was I found the resistance on one of the wire. So 800 times 0.0050 is equivalent to 4 ohms. Do you understand? So this means this wire has resistance of 4 ohms and this wire also has resistance of 4 ohms. Okay, now we want to find what is the voltage that they're getting. So V is equal to IR. So each wire is getting 0.60 is the current and resistance is 4, so 2.4 volts, right? So
Yes.
basically this wire gets 2.4 volts and this wire gets 2.4 volts, and wires are connected in series with relays. So 2.4 plus 2.4 plus 16, total is 20.8. Understood?
Yeah, thank you.
Now going to 35, what is the total resistance? After messing with our minds, they have given such a simple question. 1 over 40 plus 1 upon 120. So 1 divided by 40 plus 1 divided by 120 and 1 divided by answer. So this is 30. 30 plus 160 is 190. Okay, now between x and y, if you see, this is in parallel with these three. So this is 30 and 1 upon 10 plus 1 upon 30, 1 upon r, and 1 upon answer. So 7.5. So it is between 1 and 10, has to be this one. Okay, now then it gives us this question. So P has a total resistance of 10 ohms and Q is a fixed resistor of 10 ohms, right? The battery has an EMF 4 volts and internal resistance is negligible. The voltmeter has high resistance, so current can't flow. That's fine. Now they say the slider on the potentiometer is moved from X to Y. Okay, so when it is completely at X, right? So the voltmeter should show 4 volts. Why? Because it's covering both the resistances, right? So the reading should start from 4. It means C is absolutely wrong. Okay, so we have to now look at A, B and D. Now then it says that if the slider is moved to X, if it's moved to Y, so it completely ignores P, which means that now this will get complete 4 volts. Okay, now if Q gets 4 volts, will this show also 4 volts? So this will get 0 volts then. So the voltmeter will show the potential difference between this and this. The potential difference between this is 4 volts minus 0, which is 4 volts. So it will stay constant. Is it clear? Do you guys understand this? If this was,
Maybe.
sorry,
Maybe.
if this was like, if this voltmeter was connected, let's suppose like this, right? Like this, then we would choose this answer, because then as the slider is moved here, so it will get total 4, so it will not get anything, so it will show you 0. But right now, because the voltmeter is fixed, so when the slider is entirely moved, uh, avoiding P, then this gets 4 volts, this gets 0 volts, right? So what is the total voltage here that the voltmeter should show? 4. Do you understand?
Yeah, so why is it not C or B?
Why isn't C or B?
Yeah.
C is wrong because when the slider was at X, right? When it was at X, this would get 2 volts, this would get 2 volts. So what is the total voltage that the voltmeter should show? 4. So it should start from 4. Do you understand? So C is wrong.
Yeah.
That means C is absolutely wrong. B is showing reduction, which is wrong because voltmeter will show the total voltage because it's connected on both, right?
Okay, yeah, got it.
Now, 38. The uranium-235 may be represented by symbol 23592, which shows the numbers. What is this question even? 92 are the protons, and neutrons would be 143, and nucleons would be 235. What is this question really? When the magnesium is hit by gamma ray, sodium nucleus Na is formed, and another particles. So Mg 2512 gives Na 2411. What are the nucleon number, mass number, and proton number of the other particle produced? Interesting, huh? So the particle X will have one mass because it needs to balance and one charge. So that has to be one mass, one charge. So that has to be D. Okay. Which nuclear equation shows that the beta decay of nucleus argon into potassium K? Okay. So argon goes to potassium and it goes to a beta decay. So let's see. All of them are 40 and 19 if I see. So I'll just put 40 and 19 here. This is 0. So this will be 40. This will be 18. So do we have an answer like that? Yes, we do. 40 and 18. See. Right? Is it clear? Now, going back to the question that we are stuck on, because everything has been solved here. This question is tough. Okay. Impressive question. Okay, let me think about it. So again, let's try with X first, because there is no way you can do it anywhere else. So force over area times length is 3 and extension is 1.5. Okay, that should give us 2. And the second wire is basically right. The second wire, EY, is force over area. The length is 1, extension is 1.
Wait, sir?
Yes.
Aren't the units different? Don't we convert?
Because it's a ratio, right? So when we take the ratio, they will cancel out. So it don't really matter.
Sir.
Okay. So now EX will be equal to 2 times F upon A, and EY will be equal to F upon A, which means that actually which means that in reality Ex is equivalent to 2 times of Ey. So this is the first clue that we have. Okay. Now let me think about it. Now I'm thinking in a different way. If Ex is 2 times f upon a, and this factor 2 basically represents length over extension, right? This is what it represents for x only. So if the length of x is reduced to 1, so the extension in x will be actually this. Let me think about it. Wait a second. I think I'm getting a clue. There was there is a sort of a relationship here. 2 times x is equal to L, right? So the point is that when length was 3, extension was 1.5. So when length will be 1, what will be the extension? They're directly proportional actually. Let me think about it this way. It will be 3, and when length was 3, the extension was 1.5. When the length is 1, the extension is x. So, but that basically gives me 1.5 divided by 3. So the new extension will be equal to 0.5 millimeter. Do you guys understand this? This is for x only. Now let's do it for Ey. Ey was equivalent to f upon a only times 1, which means that 1 is equal to length over extension. So length and extension is directly like this, okay? So basically when the length was 1, extension was also 1, right? So when the length is 3, the extension should also be 3. So this means the new extension in y should be 3 millimeter. So the total extension should be 3 millimeter plus 0.5 millimeter gives me 3.5 millimeter. So that's the answer. Do you guys understand what I did here?
Wait, still the left side. What's happening there?
Okay. So this is not required at all. What I basically thought about it, that according to my equations of two equations, right? Here, let's make a table here. So you might see that for x, whether the length changes or the extension, whether the length changes or whatever, the Young modulus stays the same for x. Do you agree?
Yeah.
Right? This factor represents length over extension. So can I write, and this is equal to 2. So can I write length over extensions for x only, right, is equivalent to 2. Can I say that?
Yes.
Right. Now think about it. When length and x, when the length was 3, the extension was 1.5. Agreed?
Yeah.
So if the length changes to 1, what will be the extension in x? We can cross multiply, right?
Yeah, 0.5.
So this will, the new extension, when the length will become 1, the extension will become 0.5 millimeter. Do you understand?
Yes.
Okay. Now for y, let's do y here. Okay, for y. When the length was equal to, basically length over extension was 1. So length and x is like equal, right? But it's same proportionality. So let's write length and extension. When the length was 1, the extension 1 meter, extension was 1 millimeter. Agreed?
Yeah.
So if the length becomes 3 meters, what will be the new extension? So you cross multiply, the answer will be 3 millimeter. Do you understand in y?
Yeah, but even if they gave me an entire day for this, I wouldn't be able to do this.
So xy plus xx.
What?
So this will be 3 plus 0.5, which is 3.5 millimeter. Well, some questions are there to give you distinctions, and this is a distinction question, I think. But
So you
technically,
could guess as well.
you could, yeah, maybe you guess and you get a distinction. The point is, you see, if let's suppose our preparation is so good, right? We have managed to do 39 out of 40, even if we get this wrong, right? Still, we have a very high score. Don't you think so?
But that's impossible. It's too much.
Yes, but that's, I want to see what was the grade threshold of this. Because this is like, this paper was like, wow, man, impressive. So now you feel when I did my A levels how difficult it was, right? You guys are enjoying the time of thing. So this is 2000, and I think the threshold should be low in this 2010 winter.
Sir, electric field, we still have to study it, but it's in A2, right?
In
Or has it
electric
been
field,
removed completely?
electric field we will study in A2. It is completely shifted to A2. So component 1 1. Oh my god, look at the grade A. It's 32.
And sir, no C and
Why is that
no
so
D.
high?
Oh, I'll tell you why. I don't know why it is so high. At that time, when this was there in 2010, I gave my A levels in 2009. So at that time, there used to be percentage. There was not A star. So A means an A star here, basically. Do you understand? So between B and A, there would be like a different percentage. That's why it's like that. Old papers were like quite messed up. Now let's see what is the grade threshold of the new paper, which is 2021 March. Okay, I want to find grade threshold of 2021. So that is like, you see, 26. So this means that either the people have become dumb
Definitely.
or I'm
Maybe
looking
sir, syllabus has become hard.
or it was very hard at that time and people were very smart to do this. I don't know. But that's fine. All right. So I guess that would be the end of the class.